In this video, we're going to go ahead and cover the next part of Unit 9, Sequences, Series, and Probability, 9.2 Arithmetic Sequences, and Partial Sums. Just to kind of give a little side note here, these are actually pretty fascinating. So if anybody's interested in more about this, let me know, or just look it up. I'm going to try to show you guys some of the geometry stuff that goes with this in class, and maybe that'll, kind of inspire a little bit more math in you. But anyway, let's go ahead and get started. We have definition. A sequence is arithmetic when the differences between consecutive terms are the same. So in other words, from like this term to this term, it's plus 5 or whatever. Then from here to here, it's also plus 5. So it's the same exact addition or subtraction of numbers between two terms. And that's basically called the common difference, okay? And it tells you here a little bit more math terminology where the second term minus the first term is the same as the third term minus the second term and so forth. And this is called the common difference, okay, of the arithmetic sequence. So let's just go right into it. This is a pretty simple section here. Example number 1, we're going to write the first 4 terms of the arithmetic sequence whose nth term is 3n minus 1. Then we're going to find the common difference between those terms. So kind of like what we did before, this is our expression. So, oh, where did my pen go? It is lost. Okay, well, that's okay. I guess we're not using color for this one. So this is my expression, and we're going to just kind of plug into the first 4 terms. So think of it like this. A sub 1 would be 3 times 1 minus 1. 3 minus 1 is 2. A sub 2 is 3 times 2 minus 1. 3 times 2 is 6 minus 1 is 5. A sub 3 times 3 minus 1. 9 minus 1 is 8. And then a sub 4 is 3 times 4 minus 1, which is 12 minus 1 is 11. Okay, so the sequence, and I'm going to write it kind of like this, the sequence. I guess I'm going to put n, but just because I kind of want it to go forever. So 2, 5, 8, 11, and it just keeps going. The sequence looks like it's going by threes, if you notice. To find that, well, this from here to here, from my first term to the second term, we're adding 3. From my second term to my third term, we're adding 3, and so forth. So since the difference between numbers is just 3, that means that D is equal to 3. And this is a common difference for the sequence, which means that it's an arithmetic sequence, okay? And that's it. That's it for this example. If I wanted to find, let's say, I don't know, the 15th term, you could probably keep going. So just keep listing the numbers. But there is a faster way to do it. I'm going to show that to you in the next example. So let's move on. A nice quick video, hopefully, to make up for the previous one. So we have the nth term in the arithmetic sequence. If you're trying to find a specific term, say the 100th term, something that's way out there, you don't want to list all the numbers to get there. It's going to take forever, right? So figuratively speaking. So this is the formula we're going to use. It's a sub n is equal to a sub 1. So the first term plus that term minus 1. So whatever the term you're looking for, you just plug in that number here, the number of the term, times the common difference, where n is the nth term and where d is the common difference between the consecutive terms, and a sub 1 is the first term. So just everything I just said. Let's jump into an example. The first one is actually solved for us, and then the second one, I kind of went a little bit more, we're going to look for that one, okay? So example number 2, find a formula for the nth terms of the arithmetic sequence whose common difference is 3 and whose first term is 2. And you have the solution here. So it tells us the common difference is 3, which means that D is equal to 3, okay? And the first term is 2, which means that a sub 1 is equal to 2. So using the formula here, all you got to do is plug everything in. A sub n is, well, that's what we're looking for, right? We're looking for the formula, so we're going to leave it like that. And then we have our first term, 2 plus n. Be careful here because people tend to want to put in the value of a sub n, but actually, or whatever number it is that we're looking for. But this is just the number, basically this one. It's whatever this is, okay? So n minus 1 times our common difference, 3, And since we're looking for a formula, we're actually not going to end up with a numerical answer. We're going to just distribute. So 3 times n is 3n, 3 times -1 is -3. Combine like terms, 3n minus 1, because 2 minus 3 is -1. And that is it. Okay, that's it for that one. So once you get to this point, let's say I had asked you, give me the 500th term. All you have to do is plug it into here. Say 3 times 500 minus 1 is 1499, yeah, or whatever it is that we're looking for. That's it. Easy as that. Next example. We're going to find a specific term now, which is exactly what I was kind of rambling about a few seconds ago. It says the eighth term of an arithmetic sequence is 25, and the 12th term is 41. Write the first 6 terms. So we're actually going to find 6 terms. Sorry for all the whiteout guys. Me and whiteout, we're like mortal enemies. I kept copying the wrong problem for this one. It's a Saturday. But anyway, so the first thing we're going to do for this, because we have all we know is that the 8th term is this and the 12th term is this, is we're going to try to find the common difference. Because if we can find the common difference, all I got to do is add or subtract that to probably the 8th term, right? To figure out the rest. So we don't even have to find the formula for this one. We could. I could show you how to do it if you'd like, probably in class, because it'll be a little bit late here. But because the numbers are relatively close, we can just find the common difference and then add or subtract to get those terms. So let's do that. We know that the 8th term, so eighth of 8 is 25. So I know that one is 25. And then I go all the way to eighth of 12, and that one is 41. And then we have some numbers in here, right? And obviously it goes on. This one is not, it's not going to be finite. It's infinite, okay? So what I'm going to do is I'm going to say, well, I know that from here to here, so from 8 to 12, we have 4 terms, right? It's like subtracting. You can think of it like 12 minus 8 equals 4, okay? So between here and here, there's 4 spaces. So my common difference is actually going to be these two numbers, the value of my actual terms, so 41 minus 25 divided by that 4. And if you want to kind of write it officially as a formula, you can think of it like D is going to be equal to ace of 12 minus ace of 8 divided by the number of terms. I don't want to put, well, I guess I can put n. I'll put n star, where n star is the difference between these two right here. So this is kind of like our n star. I don't want to put n because I don't want to confuse anybody with the previous example formula, okay? So anyway, in short, just, subtract them and divide it by the average. It's what it is, the average of that. So 41 minus 25 is 16. Divided by 4 is 4. So it looks like our common difference is 4, which means all I got to do to find the first 6 terms, since I have the 8th term, I can just subtract 4 to get the other ones, yeah? To get the 7th term and then the 6th term and so forth. So let's do it this way. I'm going to rewrite this. I'm going to say, I'm going to put 25 right here. Remember, this is A8. I know it goes on. And I'm going to find the ones before it because I want the first 6 terms. So I'm going to go backwards with this one. Since I'm doing 4, it's positive 4. If you go backwards, you kind of have to subtract 4. Okay, so, but I'm going to actually write it with a plus because I'm going to pretend, well, what plus 4 is 25? Well, 21 plus 4 is 25. Okay, and then I move on. What plus 4 is 21? So yes, you're subtracting in your head, but think of it, because I want to keep this as positive. It's going to be 17. 17 plus 4 is 21. You keep going. What plus 4 is 17? Well, 13. 13 plus 4 is 17. That's going to be the 5th term. Let me see. Next one. What plus 4 is 13? 9. Remember, you're actually subtracting, okay? So please don't get confused. I kind of want to keep my common difference as it is. Next one. 9 minus 4 is going to give me 5. And if I check, 5 plus 4 is 9. That's the 3rd term. Next one. 5 minus 4 is 1. And if I check, 1 plus 4 is 5. And last but not least, I'm almost out of space here. 1 minus 4 is -3. And if I check, -3 plus 4 is 1. So it looks like these right here are my first 6 terms, which is what I was looking for, okay? And again, you can also find the formula and just plug it in and then do each one. But in this particular example, this was just the faster route to go, okay? Let's look at another part of this unit. We have the sum of a finite arithmetic sequence. So we did talk about summations in the previous one. That was the one with that weird looking like E thing. Okay, it's called a summation. But now we have another formula for a finite sequence, but it has to be arithmetic. So that means that the only way this would work, this formula, is if the sequence that you have has a common difference. So I just put here it must be arithmetic, which means it has a common difference. Okay. The formula is the sequence of whatever you're of the sum of the sequence that you're looking for is going to be n, so the number of terms that you're looking at divided by 2, and then you add the first term and the last term, and that's it. So let's look at an example. We have find the sum of the integers from 1 to 100 and from 1 to some random number n. So let's do this one first. Just to kind of show the point here, we know that 1 to 100, we're just basically going by 1, right? We have plus 1, plus 1, plus 1. So D is equal to 1. It has a common difference. We're just going to be adding 1 to get there, okay? And that means that it is going to be arithmetic. So it is arithmetic, so we can use this formula, okay? So what's what? Let's see. Well, S of n is just this. So S of n is my sequence here, okay? N is going to be equal to the number of terms, so up to 100. So n is 100. And oh, actually, I'm sorry. S of n is the summation. I meant to put pluses here. All the way to 100. There we go. Yeah, because we're looking for a sum, not a list here. So n is the sum of 1 plus 2 plus 3 plus 4 all the way to 100. Okay, S of n. N is going to be there's 100 terms, and we also need to know ace of 1. So ace of 1 is our first term, and then ace of n would be ace of 100, which is, well, just 100. Yeah, because it's the last term. So let's just plug everything in. We're going to have that the sum of all these integers is going to be 100 divided by 2 times my first term plus the last term. Very simple. This is 50 times 1 plus 100 is 101. And if you multiply this out, ooh, I'm going into the space over here. If you multiply this out, 50 times 101, well, 50 times 1 is 50. 50 times the other one is also 50. So you actually get 5,050. You can check my math if you don't believe me, but I promise you that's correct. And that's it. That's it for that one. Nothing else to do. Okay. Let's do the more general form where you have 1 to n, just some random number integer n. So for this one, we're thinking S of n is 1 plus 2 plus 3 plus all the way to whatever n is. So when I plug this into my formula, well, let's label everything. Ace of 1 is going to be 1. Ace of n is going to be n. I guess I should leave it as a little n here. We'll just leave it like that. No confusion. So first term, last term, and what else do I need? That's all I need. So S of n is going to be equal to capital N over 2. Okay, that's the number of terms. Oh, I'm sorry. That's what I meant to do right there. There you go. Okay. Times ace of 1. So ace of 1 is just 1. And ace of n, it's kind of the same thing here because we don't know what the value is. So we have to use our n for that. So that's it. And that's all you can do with this problem because we don't, oh, there's my pen. We don't really have any other information. Okay, so we're going to leave it like that. And that is it for that problem. Okay, let's move on to the next one. So I actually did not want to do this problem together because the answer's in the books. If you want, you can copy it, but we're going to do a different example 5. This one is in the book, so I want to do the one that you don't have an answer to. So I chose the one underneath it, which is not given, and I figured I will show you this one. So here's example 5. It's find the 30th partial sum of the arithmetic sequence, and then we have the following, okay? So we're going to do a few things with this. First of all, partial sum means that we're just looking for that the sequence is going to go on forever, right? But we only want up to a certain point. So in this one, we have the first term, we have the second term, the third term, the fourth term, and the fifth term. But we need to go all the way to 30, okay? So what we're going to have to do first, before we even use our formula for our step 1, is we're going to have to find a sub 30. So we need to find a sub 30, the 30th term. How are we going to do that? Well, we have another formula, remember, that we saw previously, this one, for how to find a term. So we're going to have to use that one. So let's put that in parentheses. A sub n is equal to a sub 1 plus n minus 1 times d. And we have a sub n, we have a sub 1, because a sub 1 is that one. We have n would just be equal to 30. Okay, the number of terms that we're getting to. But we don't have d, so we're going to have to find d. How do we do that? Well, d is just the common difference. Remember, this is the common difference from one term to the next. So if I look up here, and I guess I can write it again if you want, just so you can kind of see the pattern. Oh, that's a 7. My eyes are just seeing different things today, copying all the wrong things. From here to here, we go down by 2, subtracting 2 all the way. So it looks like our common difference is actually going to be minus 2. Okay, now that we have everything we need, we're going to go ahead and plug it into this formula to find a sub 30. And then once we find a sub 30, then we can use our formula from before to find the sum from this number all the way to whatever this is equal to. Okay, so let's try that. We're going to have a sub 30 equals a sub 1, which is 78, plus n minus 1, n is just 30, times d, which is negative 2. We work this out. Let me move this up a little bit. So I have 78 plus 29 times negative 2, which would be 78. 29 times negative 2 is negative 58, so minus 58 equals this minus this is just 20. So this means that my 30th term is 20. Okay, so now we have our term, we have the first term. So step 2 is to use the other formula. So now we're going to use our formula for the sum of the partial sum. So that's going to be n over 2 times a sub 1 plus a sub n. What is S sub n? Well, this is S sub n is the summation. So 78 plus 76 plus 74, all the way till we get to this 20. Okay. And yes, you could do it by hand, but I feel like that would take an incredibly long time. So let's just use the formula. Yeah, whoa. My Elmo is acting a little weird today. Okay, so let's use the formula. S of n is equal, oh, well, I should have put a 30 there. S of 30, okay, is going to be the first term, I'm sorry, n, which is 30, over 2. A sub 1, that's the first term, so 78, plus a sub n. So what is a sub n equal to? What was this equal to? It was equal to 20, so 20. We're going to do this all mental in our head. 30 divided by 2 is 15. 78 plus 20 is 98. How do you multiply this in your head? Well, what I would do is I would say I'm going to multiply it by 10 and then take half of it, because 15 is 10 plus 5, right? So 10 times 98 is going to be, think of it like this. 10 times 98 is, oh, we'll put it on this side, is 980. Okay, then 5 times 98, well, it's just half of this one, right? So half of 980 is 490. You add those two up, so we should be getting 0, 7, and 14. So our answer for this is 1,470, which means that from 78 all the way to this 20, if you add them up, that's what you get. Okay. And that is it, guys. That is it for this video. If you have any questions, as always, let me know.